Hello, dear students. I am Aditya Gupta, and a very warm welcome to this first lecture on the topic of pair of linear equations in two variables. Now, in board exams, this is a very important chapter. It has a weightage of around 6 to 8 marks, right? So, let us have a look at this chapter very carefully and let us start with the very basics. Okay. So first of all, what are the topics that we'll be covering here in this chapter? Those are, first of all, what we mean by simultaneous equations in two variables, then solving a pair of linear equations, and then the methods by which we can do, in particular, the substitution method itself, right? Now, let us talk about what we mean by simultaneous equations in two variables. So, two linear equations in two variables, when they are taken together, are called simultaneous linear equations. An example can be this one shown here. Look, we are given this example, right? So, this is called a simultaneous linear equation, or we can also say pair of linear equations in two variables, right? So these are simultaneous equations. What do we mean by the word simultaneous? That x and y simultaneously satisfy both of these equations. Simultaneous means at the same time. So x and y are such numbers which satisfy this equation also, and they satisfy this equation also, although here they represent the same equation. So let me take a better example, like 2x plus y equal to, let's say, 8, and let's say x minus 3y is equal to 10. So, so this is actually a correct example. This actually represents the same line. So there is no point taking this example. The only thing that this example illustrates is that this equation and this equation are the same thing, because if you multiply this equation by 2 on both the sides, you will obtain this equation. Okay, this equation. So that is not the point here. What we are talking about is that two linear equations in two variables taken together at a time are called simultaneous linear equations. Okay. Now, solution of simultaneous linear equation is the ordered pair x comma y which satisfies both the linear equations. So what we are saying is, consider this linear equation. Of course, this is a linear equation because the power of x and power of y is 1. So this is a linear equation in x and y, no doubt. Then this is also a linear equation in x and y because the powers of x and y are 1 and 1, right? So clearly both of them are linear equations in the variables x and y, that's for sure. Now, why are we calling them simultaneous equations in two variables? Because x and y should satisfy both of these equations at the same time. You understand? So for instance, if I choose x equal to, let's say, 0 and y equal to 8, so indeed these set of values are satisfying this value, this equation. Because if you put x equal to 0 and y equal to 8, this particular equation is satisfied. But they do not satisfy this particular equation, right? If you put x equal to 0 and y equal to 8, clearly this is not satisfied. So this will not be regarded as a solution. And that is the reason why we call them simultaneous equations, because they should be satisfied simultaneously. We have to find a solution set x comma y, which are such values of x and y which not only satisfy the first equation but also the second equation. So at the same time, the values should satisfy both the given equations. That's our main goal here. That's why we are calling them pair of linear equations or simultaneous linear equations in the ordered pairs x and y. Okay, and solution which we are talking about is what? Solution actually means the actual values of x and y which satisfy the given equations. Okay, so I hope this simultaneous equation or pair of equations is clear to everyone. And of course, linear equation means that the power should be 1. Okay, now solving a pair of linear equation, for example, here we are given this kind of an example here, that we have two equations. Okay, solve this and this. So first of all, let us only talk about one equation, not a pair of equation, just one equation let us talk about. So look, if we just talk about one equation, there can be infinitely many solutions here. Okay, so for instance, if you put x equal to 0, y equal to minus 17 by 9, then of course these values of x and y satisfy this value. Yes, if you put x equal to, let's say, something like minus half, let's say, and y equal to, let's say, you say, or let's say plus half. Okay, just let us take it plus half only. So if x is half and y is minus 2, then clearly this is also a valid solution of this equation, right? Similarly, basically what we can say, you can take any value of x. You can take any random value of x that you wish. Let's say you want to take 10.2, no problem. Then y will come out to be from here, minus 17 minus, what is twice of 10 by 2? It will be 20.4 divided by 9. Whatever this value comes out, that value of y you can take. So obviously they will satisfy this equation. So what we are saying is that if there are two variables but only one equation, then there will be infinitely many solutions. Okay, but if there is another equation which is also to be satisfied, then there will not be infinite solutions. For example, in this case, clearly this satisfies this equation, right? But does this also satisfy this equation? No. If you put x equal to half here, if you put y equal to minus 2 here, are you getting 20? No, this is not true. And hence, we conclude that although there are infinitely many solutions to one linear equation in two variables, but if there are two equations in two variables, then it is not the case that there will have to be infinite solutions. So what we mean by solving a pair of linear equations is that we try to find the values of x and y which actually satisfy both the equations given. So for instance, if I take the example, let's say x plus 2y is equal to 4, and let's say, let us say 3x minus y is equal to, let us say something like 5. Okay. Now let us say I want to find x and y which satisfy both of these equations simultaneously. So how can we do that? Well, maybe by hit and trial, you might be able to observe x equal to 2, y equal to 1 is a solution. Correct? However, by hit and trial, we cannot be sure that we'll always be able to find the solution, right? For instance, in this case, we might have found, but what if it was a difficult question? Our hit and trial guessing, estimating trick might not have worked, right? So we need to devise clever ways, clever methods, which will guarantee a solution every single time, no matter how hard the question is. We don't have to rely on methods of hit and trial. That's what we want, right? So before we move on to those methods, we must first understand what we actually mean by solution of a simultaneous pair of linear equations. Basically, solution means values of x and y which actually satisfy both the equations. Okay, clearly here 2 and 1 are actually satisfying. Look, if you put x equal to 2 here and y equal to 1, you are actually getting 4. So this is indeed satisfied. Correct? If you put x equal to 2 here, 3 to the 6 minus y, which is 1. So 6 minus 1 equal to 5 is indeed satisfied. So yes, this is the correct solution. Okay. Now let us say, if you talk about another solution, let's say x equal to 0 and y equal to minus 5. So yes, this is also satisfying this equation, but this is not satisfying this equation. So this is not a solution because both of them should be satisfied. That's what we call a solution. Okay. So now let us move on to the next slide. Okay. So here we have a question, but right now let us just form the equation. We will solve it later. Okay. So how do we form a pair of linear equations? Let us learn that. If twice the age of son is added to the age of father, the sum is this much. If twice the age of father is added to the age of son, the sum is this much. Find the ages of father and son. So look, what we can do is, let us say the age of son, let us say we assume it to be S, and let us say the age of father, we assume it to be F. Then twice the age of son added to the age of father, the sum gives us 56, okay, 56. But if twice the age of father is added to the age of son, the sum is 82. So we have formed the linear equations, okay. So formation of pair of linear equations in two variables s and f. S and F, we have formed this. So formation we have learned that how from a given information in the form of word problem, how we can convert it into equations. That we have learned here. How to solve, we'll learn later in just a moment. But first we need to understand how formation takes place. Okay. Now let us actually learn the very first method to solve a pair of linear equations, which is the substitution method. The method of substitution actually involves three steps. The very first step is solve any one equation for one of the variables. Okay, substitute or plug in this expression which was obtained in first step into the other equation and solve. Resubstitute the value into the original equation to find the corresponding variable. Absolutely correct. Okay, so let us actually have a look at this method in action so that you understand how we should apply this method. So okay, this is a very easy example. Let us actually take this example only. So what does it say? That from one equation, solve for one of the variables. So let us say from equation 1, I want to solve for f. So how much does f come out to be? F will come out to be 56 minus 2s. What has happened? This 2s term we have transferred here, transposed to the other side, so it becomes minus 2s. So this is the value of f. F is equal to 56 minus 2s. Now just put this value of f in the second equation. That's it. So we substitute this value of f in this equation. 82 is equal to s plus twice of f. What is the value of f equal to? 56 minus 2s. So just put it here, 56 minus 2s. Once you do that, what are we getting? We are getting, what is twice of 56? 112 minus 4s plus s is equal to 82. So what are we getting? Bring this 82 here, take this 4s minus s on the other side. So we will get 112 minus 82, which is 30, equal to 4s minus s. From here you get 30 equal to 3s. So s equal to 30 by 3, which is 10. So son's age we have got 10. Now how will you find father's age? Just substitute in this equation. So f will be equal to 56 minus 2 into s. What is the value of s? 10. I have just put the value of s. Okay. So this is coming out to be 36. Correct? 56 minus 20 is obviously 36. So 36 years will be the father's age. Okay. And 10 years will be the son's age, which will be our correct answer, as given in the solution as well. Okay, so the same equations have been formed, and then we will try to solve them to get father's age as 36 and son's age as 10 years, right? So now let us also try to solve this question. So look, from this equation, first of all, let us divide both the sides by 3. Okay, the reason is that how can we simplify this equation? We can first write minus 3. If I take common, inside we will be left with x plus y equal to 3, correct? So from here I have taken minus 3 common, and from here y is already written as minus 5x minus 17. So we don't even need to separate y. We don't even need to solve y in terms of x, since it is already solved. So first of all, 3 and 3 will cancel out here. So on simplifying, this equation has become x plus, now take this minus 1 here. Okay, so when you will do that, x plus y will come out to be minus 1. Now now substitute the value of y. How much is it? X plus minus 5x minus 17 will give us minus 1, correct? So what are we getting? We are getting, let us see what we are getting. Let us multiply both sides by minus 1. So minus 1 into minus 1 will be 1. And here it will become minus x plus 5x plus 17. So we are getting 17 minus 1 will be 16. Okay, just bring this here. And 5x minus x will be 4x. Okay, so x comes out to be minus 16 by 4 minus 4. So x value you have found. Put this value here in this equation, substitute this value of x equal to minus 4. So you get y equal to minus 5 into minus 4 minus 17. This gives us 20 minus 17, 3. So x equal to minus 4, y equal to 3 will be the answer. Okay. So I hope this is clear to everybody. Now look in the solution also. We have substituted this value of y here in this original equation. Here it is not simplified the equation by cancelling the 3. No problem. That is also fine. So when we are substituting this value of y here, look, here we have substituted this value. Okay, now on opening the brackets, we are getting this equation, and on simplifying, we are getting 12x, okay, plus 51 equal to 3. Subtracting, so taking 51 here, we get 3 minus 51. 12x becomes equal to minus 48. Dividing by 12, x equal to minus 4, that we have got. Substitute this value of x back in the equation, original equation here, and then we get the value of y equal to 3. So that's it. The question is solved. Solution we have basically found, right? Now let us have a look at some of these practice questions. The sum of two numbers is 14, okay, and the difference is to find the numbers. So let us say the numbers are x and y, and let us say x is the greater number, y is the smaller number. Then the sum is given to be 14, and since x is greater, the difference is 2. So how can we solve these equations? It's actually very easy. Just from this equation, what can I say? X equal to y plus 2. Just substitute this value of x in this equation. So you will get you will get 14 is equal to x plus y. Instead of x, I will write y plus 2. Okay. Now, once we do that, we are getting y plus y will become 2y plus 2 equal to 14. Take this 2 here. 14 minus 2 will give us 12. Y equal to 6 because 12 upon 2 is 6. Just put this value of y here. So you will get x equal to 6 plus 2, which is 8, which is the solution as well of this question. Okay. Now let's talk about first this question. This seems to be easy. This is a word problem, so this also will solve. But first, let us have a look at the third question. These two equations are given. So let us solve for x from this equation, let us say. So we'll get 2x is equal to 3y plus 5. What have I done? This term and this term I have taken on this side. Okay, transposed to the right hand side. So x comes out to be 3y plus 5 whole divided by 2. Okay, I have taken the 2 here. Now put this value of x in this equation. So what are we getting? 5 into x is equal to 3y plus 8. Okay, so what I have done is 3y and 8 I have taken on this side. Okay, and after that I have just put the value of x. Okay, now look what we are getting. In fact, it would have been better if we would have substituted y in terms of x. Okay, so both the methods I will tell. First, let us understand with this way. So let us just take this 2 cross multiply. So 50 here we will get multiplication 15y plus 75. Here we will get 2 into this entire thing. Okay, so it will become 6y plus 2 8s are 16. On bringing this to this side, we are getting how much? 9y plus what is 75 minus 16? It will actually be let's see, 75 minus, yeah, it will be 59. So we are getting y equal to minus 59 upon 9. Okay, now let us also look, and of course x value can also be found just by substituting the value of y back into this relation. So we might have actually done some mistake. Let us have a look what mistake we have done. Let me erase this once again. Look, because it has become a little bit of a mess, so let us solve this clearly. Okay. All right, so now look, let us have a look here. We have this equation 5x minus 3y minus 8 equal to 0, and 2x minus 3y minus 5 is equal to 0. So look, what we are doing is From this equation, I am writing 2x is equal to 3y plus 5. So what are we getting? We are getting that we are basically getting something like x is equal to 3y plus 5 by 2. Okay. So if you substitute this value of x here in this equation, you are getting, look, first of all, this equation becomes 5x is equal to 3y plus 8, correct? Now you substitute the value of x here, you will get 5 into 3y plus 5 by 2, okay? 5 into 3y plus 5 by 2 equal to 3y plus 8. So what do we say from here? That 5 into 3y plus 5 will be equal to, just take 2 here, 2 into 3y plus 8, cross multiplication we have done. On opening the brackets, we get 5 3s are 15y plus 25, okay? Yeah, in the previous solution, we had done a incorrect multiplication. 5 into 5 will be 25, and here 6y plus 2 8s are 16. Now from this equation, we will get 15y minus 6y will become 9y, and 25 minus 16 will become 9, correct? So y will be minus 9 by 9, which is minus 1. And when you put this value of y as minus 1 here, you get the value of x as 5 minus 3, 5 minus 3 by 2, or minus 3 plus 5 by 2, which is 2 by 2, which is 1. So we can say x equal to 1 and y equal to 1 will be the solution. Now another solution, let us have a look. Another solution would be that you can write from the first equation that y is equal to, look, we are given 5x minus 3y minus 8 equal to 0. So from this you can write another method I am telling you. Okay, this is method 2. We can write 3y is equal to 5x minus 8. I have just taken this here. And then y will be equal to 5x minus 8 by 3. Now this value of y you substitute in the second equation. What is the second equation? 2x minus 3 into y. Then minus 5 is equal to 0. Okay, minus 5 is equal to 0. 3 and 3 of course cancel out, so we are left with 2x minus 5x plus 8. Due to this negative sign, the signs are changing. Okay, so this has become minus 5x, this has become plus 8. Okay, and then minus 5 is equal to 0. So what are we getting? 2x minus 5x will be 3 minus 3x plus 3 is equal to 0. Take this here. So 3x equal to 3. So x comes out to be 3 by 3, which is 1. Substitute this value here. So 5 into 1 will be 5 minus 8 by 3 minus 3 by 3 minus 1. So y will be minus 1. X will be 1. That is the solution. Okay. So that's the way we will solve. Now let us have a look at the second question. In a 2-digit number, the unit digit is thrice the tens digit. If 36 is added to the number, digits interchange their places, then find the numbers. So let us say the digit itself looks something like this. Unit digits is B and tens digit is A. What are we saying now? Units digit is thrice the tens digit. Okay, so units digit is thrice the tens digit. If now look, what is this number? How will we represent this number? In expanded form, it will become 10 into A plus B, right? So if 36 is added to this number, the number is reversed. So reversed means it should look like this. So what will this number be in expanded form? 10B plus A. So now look, from here, what are we getting on simplifying? 10A minus A will be 9A. I have just taken it here, okay? So 10A minus A will be 9A plus 36. Now take this B here. So it will become 10B minus B, which is 9B. Divide by 9, both the sides, you are getting A plus 4 is equal to B, okay? So that's what we are getting. So these two equations are there. So substitute this value of B in terms of A in this equation, you will get, instead of B, I have written this 3A value. So you get 2A is equal to 4 because 3A minus A will be 2A. A comes out to be 2, and from this equation, B will be 3 into 2, 6. So what will be the number? It will be 26, okay? And you can check also, if you clearly the units digit is thrice of this, And if you add 36 to this, what are you getting? You are getting 62. Okay. So clearly it has reversed. 62 and 26, the digits have reversed. Okay. Now let us take another good example. Let us say we are given the equation 2x plus 3y is equal to, let us say, 5, and let's say another equation we are given 4x plus 6y is equal to minus 10, let's say. So how do we solve these two equations? Now look, please carefully, you should all note what happens in this equation. In this particular example, we observe that x comes out to be 5 minus 3y upon 2, correct, from this equation. If you substitute this value of x here in this equation, you are getting 4 into 5 minus 3y upon 2 plus 6y is equal to minus 10. So here this gets cancelled with a 2, and if you open this bracket, you will get 10 minus 6y plus 6y is equal to minus 10. 6y get cancelled. We are left with 10 equal to minus 10, which is obviously never true. It can never be true, right? So since there is such a condition which can never be true, we can say that this equation has no solutions. Okay. It has no solutions means there are no values of x and y, absolutely no values of x and y that satisfy both these equations. Okay. Because this can never be true, right? So no matter what x and y you put, these two equations will never be simultaneously satisfied. Okay. Now let us take another example. The example can be something like x minus 2y is equal to, let us say, 7, and 3x minus 6y is equal to 21. So what about these two equations? What can we say? Let us see. For instance, if you, from this first equation, if you substitute x equal to 2y plus 7, and then put this value here, substitute it here. So 3 into 2y plus 7 minus 6y equal to 21. I have just put the value of x as this one. So what are we getting? 6y, okay, 6y plus 21 minus 6y equal to 21. So obviously this and this get cancelled and we get 21 equal to 21. So clearly this always holds true. This is always true for all values of x and y. No matter what you put x and y, this will always be true, right? So that's why we are saying that this will have infinite solutions, infinitely many solutions. Okay. For example, x equal to 0 and, or let us say something like y equal to 0, x equal to 7 is a solution. We can also say, for instance, x equal to 1 and y equal to minus 3. This is also a solution. So there are, because these values are satisfying both of these equations. These two values are also satisfying both these equations. Okay. So there will be so many equations. In fact, you can put any value of y as k and x value as 2k plus 7, and you will observe that for all values of k, this will be, both of these will be satisfied. So this is always a solution to both of these equations. You can actually check, put any value of k. Let us say you want to put minus 10. So then y you will get as minus 10, x you will get as minus 20 plus 7, which is minus 13. You check this, whether this equation is being satisfied or not by x equal to this, y equal to this much, and x equal to this much. You will see that yes, this is also satisfied, this is also satisfied. So that's what we are saying, that in this case there will be infinitely many solutions. So here we have seen many different types of cases on how to solve the equations, right? And we have also seen when there are cases of infinite solutions and no solutions, right? So let us take just one or two more examples, then we will call it an end. So let us take here an example which looks something like this: 3x plus 4y equal to let's say 8, and x minus 2x minus 5y equal to minus 3, right? And so let us try to solve this. First method can be that from this equation, let's say you want to separate out x. So if you solve for x, you will get 3x is equal to 8 minus 4y correct, first step. Then x comes out to be 8 minus 4y upon 3, correct. Now put this value of x, substitute this value of x here in this equation, you get twice of x, and x value I have substituted from here only, minus 5y equal to minus 3. Now solving this, let's see what we are getting. Just multiply by 2, you are getting 16 minus 8y upon 3 equal to 5y minus 3. I have taken this 5y here, right? Now cross multiplying, we get 16 minus 8y equal to 3 into 5y minus 3. This gives us 15 y minus 9. So from these two equations, what can we say? That if you bring 9 to that side, you will get 16 plus 9. And if you take 8y to this side, you will get 15y plus 8y. I hope this point is clear to everyone. That, look, 16 minus 8y equal to 15y minus 9. So I have transposed 9 to LHS, so it will become plus 9. 8y I have taken to RHS, so it will become plus 8. Okay. So here we are getting 16 plus 9 is 25 equal to 15 plus 8, 15y plus 8y is 23y. So y we are getting as 25 by 23. Okay. Now what about x? So from this equation, we will get x would be equal to, look, can I write this as 1 by 3 times 8 minus 4y? Correct. So this becomes 1 by 3 times 8 minus 4 into 25 by 23. Okay. That's what we are getting the value of x. Now let us try to simplify this. Let us try to simplify this here. X will come out to be 1/3 of 8 minus. Now what is this value? 4 into 25? It will be 100 upon 23. Okay. Because 4 into 25 by 23 is this much only. Now taking LCM, we will be left with 8 into 23 minus 100. What is 8 into 23? 184. Okay. So on subtracting, we are left with 84 by 3 into 23. Okay. And this gets cancelled here, and we are finally getting 28. Okay. So x is equal to 28 by 23. Okay. So this is the solution. X value is this much. Y value we have already found here, 25 by 23. And these are the solutions to the earlier questions which we had seen. The number 26 which we had found. Okay. Two numbers 6 and 8, x equal to 1, y minus 1. These are the solutions to the practice questions that we had seen earlier. So I hope you all were able to understand what was taught in this lecture and found this interesting. And you know, the method of substitution was a very important one that we have seen, and that is I hopefully have made clear to you all. Thanks a lot for watching. Stay safe and enjoy, and bye bye.